હેલો ફ્રેન્ડ્સ, સ્વાગત છે આપ સૌનું મારી યુટ્યુબ ચેનલ ફિઝિક્સ ઇન્ફાઇનાઇટમાં અને હું છું કૌશલ જોલાપરા. મારા વિડીયોઝમાં આપણે એન્જોય કરશું કોલેજ ફિઝિક્સના ઘણા બધા ઇન્ટરેસ્ટિંગ એવા ટોપિક્સ. તો આજે આપણે શરૂઆત કરવાના છીએ આપણા ફર્સ્ટ ટોપિકથી કે જેનું નામ છે વેક્ટર એલ્જિબ્રા. ફ્રેન્ડ્સ, વેક્ટર એલ્જિબ્રા ઇઝ અ બેસિક ટોપિક, વેરી ઇમ્પોર્ટન્ટ ટોપિક and easy topic to understand the physics. So to start the vector algebra, we want to understand what is scalar and vector quantity. Start with define what is scalar quantity. Let assume a simple ball. Here our simple ball, a steady ball which is not in any type of motion. In this condition, it has some quantities which does not depend on direction like temperature, mass, potential energy, charge, work, entropy, speed, volume, density, etc. And these all quantities are known as scalar quantities. So these quantities does not depend on direction. To describe this quantity, we don't want to describe its direction, and these quantities are known as scalar quantities. So next, we define the vector quantities, and for this, consider this ball in 2 or 3 dimensional space with coordinates. So this is our 2-dimensional frame, and here our ball with the coordinates x and y. If I apply the force in positive x direction on this ball, force F, so we all know what happened. The ball displaced also in positive x direction with the velocity and acceleration. The quantity in which the direction is important to describe, the quantity is known as vector quantity. So what is want to say that if I want to describe the force, I also want to describe its direction, because when direction change, the effect of quantities are changed. Like if I apply the force on this ball, if I apply the force in positive x direction, then the result is it's displaced in positive x direction. But if I apply the force in positive y direction, then it's go on upward direction. So as I say, if I change the direction, the effect of the quantity is changed, the effect of force is changed. And same rule for velocities and acceleration. So here force F is in x direction, also the displacement, velocity, acceleration are also in positive x direction. So this quantities, force, velocity, displacement, acceleration, fields, etc. are the vector quantities. So here in previous slide I mentioned speed as a scalar quantity and velocity as a vector quantity. So there is a little question that what is different between speed and velocity. So this different is only that the speed is magnitude of velocity. If I say that ball goes with the 5 km/h speed, this is the speed of ball. But if I mention the direction with this ball, that I say the ball goes with 5 km/h in positive x direction. So here I mention the direction also with the speed. And when the direction is combined with speed, then it's become velocity. When the direction is combined with any scalar quantity, it becomes vector quantities. So now I think it's clear the difference between speed and velocity. Speed is just a magnitude of velocity. And vector quantity are denoted by the symbol of arrow on the head of quantity and the symbol as vector A. Here I read it as a vector A. So this is the simple understanding about vector quantity. Now let's see some algebraic operation. And first we see the addition of vector. So again consider the two-dimensional frame. And in this two-dimensional frame we draw our vector. So here our two-dimensional frame, and we start from point A and draw a vector to the point B and named this vector as vector A, or also we can see is as vector AB. And now again draw a vector B from vector B to the point C. From point B to C, here draw a second vector and name this vector as vector B. First I go from A to B, then I go A to C and name the vector A and B respectively. And now draw the direct vector from A to C. So this vector from A to C is the addition of both vectors. So this is how the vector added. So here it is similar, like if I go from A to B, then I go from A to Z is equal to directly I go from A to C. So this is the simple understanding about addition of vector. There is another method to find the sum of the vectors. So for this we again describe it in our two-dimensional frame. First we draw our vector A. Then we draw vector B, as the tail of vector B and vector A are coincide. As we can see in figure, tail of both of these vectors are coincide. Now we draw the adjacent of both of vectors. As I draw the adjacent of B on the head of vector A and adjacent of A on the head of vector B. So here both the tail of both of vectors are coincide and the head of both of adjacent vector are coincide. So if I join this coincide tail and coincide head, it gives me the addition of both of these vectors. Okay, so this is the method of a parallelogram, paralleloped. So let's see its theoretical parts. So this is the first method, and this is the figure of first method. If A and B are two vectors to be added, the tail of B coincide with head of A, as we can see in figure. The tail of B is coincide with head of A. The vector joining the tail of A with the head of B is the vector sum of A and B. The vector joining the tail of A and head of B is the vector sum of vector A and vector B. So this is the first method. Now let's see the different way or the different method. So the figure of different method is like this. As the both vectors are separated by some angle and tail of both of vectors are coincide at the A, and we can take its adjacent sides, as adjacent sides of B is vector B is BD and adjacent side of vector AB or vector A is CD. So we draw the vector A and vector B with both tails coincide and draw its adjacent side as given in the figure. Now taking there to the adjacent side, we complete the parallelogram. So this is the quite simple. This is only the theoretical portion for how we can write this operation. So the diagonal through the common tail give the sum of the vectors. The diagonal AD through the common tail of vector A and B and to the D, this AD gives the sum of two vectors, and sum of two vectors is also vector. Vector plus vector is also a vector, and here our sum is vector AB plus vector AC is equal to vector AD. So this is the simple understanding about addition of vectors. Now the sum of vectors is also a vector. So what is the magnitude of this vector A plus vector B? So for this we can draw again this second operation of parallelogram, and this in this operation or in this figure we can add one more point, which is point E. Here we expand this line AB up to the E and draw a perpendicular line DE to the AB. And here both vectors are separated by angle theta, and it makes a true triangles, right angle triangles ADE and BDE. Now suppose magnitudes are A is equal to and B is equal to B. Vector is equal to A. It means that vector A is side AB. So A is the length of side AB and B is the length of this side AC. Angle between A and B is theta, as we see in figure. So from the Pythagoras theorem, if I apply the Pythagoras theorem on this right angle triangle ADE, it gives me the AD square is equal to AB plus BE, this lower side, plus DE, this side square. AB plus BE whole square plus DE square. So and in above figure, from triangle BDE, we can write cos theta is equal to BE by DB is equal to BE by B. So as we see, DB is the adjacent side of vector B, and so the length of both of this side is same. So as the length of AC is B, so also the length of DB is also B. So from this we can write BE is equal to B cos theta, and this value we want to put in this equation in place of BE. Now also second thing is DE. So we need to find DE also, and to find DE we can use same method, but in this method we can use sin theta is equal to DE by DB. So as we know DB is equal to B, then DE is equal to B sin theta. So this is the value of BE and DE which we want to put in this equation. Now the value of AB is same as the value of vector A, and which is A. So I put all this value in this equation, and then we can write this equation as A plus B cos theta whole square plus B sin theta square. Now if I give the square both of this bracket, then it's become A square plus 2AB cos theta plus B square cos square theta plus B square sin square theta. Now from this B square cos square theta plus B square sin square theta, B square takes common, and cos square theta plus sin square theta becomes 1. Then we can write A square plus B 2AB cos theta plus B square. So AD square is equal to A square plus 2AB cos theta plus B square. And here as we know AD is equal to A plus length of this summation vector A plus B. Okay. Thus the magnitude of vector A plus vector B is in mod vector A plus vector B is equal to under root A square plus B square plus 2AB cos theta. Here if I write any vector in mod, it means that I want to describe its magnitude. So the magnitude of addition is described as under root A square plus B square plus 2AB cos theta, and this is the important equation for the magnitude of addition of vectors. So now we see the subtraction of vector. Subtraction of vector is not like that we can directly subtract vector B from vector A. So for this, let's consider a two-dimensional frame and draw a vector B in this frame like this, and also draw a vector A like this. Both are separate by angle, and the tails of both vectors are coincide. So to subtract the vector B from vector A, we want to draw inverse vector of B and then add this inverse vector into vector A. Then it gives us the subtraction of vector A and B. So this inverse vector is vector minus B, as we draw in this blue color vector. And now we have two vectors, vector A and minus vector B. So now the addition of both of these vectors gives us a subtraction, and this is same as the method of parallelogram. We can take a adjacent of vector minus B and adjacent of vector A, and then draw a diagonal from the common tail of the both vectors, and which gives us the addition of both of vectors. But here the addition is in between vector A and vector minus B, then it resulted in vector A minus vector B. So it resulted in subtraction of vector. So this is the method how we can subtract a vectors. So this is the simple figure of subtraction of vectors. Now let A and B two vectors. We define A vector A minus vector B as the sum of vector A and vector minus B. So as I mentioned, for the subtraction we can take a inverse of vector B, and this is minus vector B. Then we can add this inverse in vector A. So this gives us vector A minus vector B. So this is quite method of subtraction. Invert the direction of B and add to A. As I mentioned, invert the direction and it's become minus b, and then add to a, and vector a plus vector minus b is equal to vector a minus vector b. Angle and magnitude of a vector a minus vector b is now vector a minus vector b whole square is equal to a square plus b square minus 2ab cos theta. So here there is little difference. In addition, this is a square plus b square plus 2ab cos theta, and in subtraction it is vector a minus vector b whole square is equal to a square plus b square minus 2ab cos theta. So here there is a little difference of sign. So the magnitude is, we can write in mode as vector a minus vector b is equal to this. Now representation of vector in terms of unit vector. Now this is very important topic and necessary topic to understand the vector algebra, that how we can represent the unit vectors and any vectors in terms of unit vectors. So this is no more complication in this topic. Let us assume a three-dimensional space and draw a vector with the three unit vectors. So these three unit vectors are I caret, j caret and k caret. Here I caret is the unit vector in the direction of x, k caret is the unit vector in the direction of z, and j caret is the unit vector of direction in y. So this is the standard notation for describe the unit vectors. In some books there is another notation are used, but this caret notation I caret, j caret and k caret are the standard notation to describe the unit vectors. Here the role of unit vector is as same as the role of 1 in scalar quantities. If I multiply any quantity with 1, there is no change. The quantity remain same. Similarly, in vectors, if I multiply any quantity with unit vector, so also it remain same. There is no any change. So here our vector with the unit vectors, and we give name this vector as vector A, and there is some parameters or distance parameters with this x, y and z axis. Here OP, OQ and OR. OQ is AX, OP is AY and OR is AZ. So AX I caret plus AY j caret plus AZ k caret, it is the represent of this unit vector A. So today we learn about addition, subtraction and how represent the vectors. And in the next lecture we learn about multiplication of vectors in different manners. તો મળીશું હવે સીધા નેક્સ્ટ લેક્ચરમાં. તો ત્યાં સુધી જય હિન્દ, વંદે માતરમ.